in this video tutorial, we will look at how we can fine-tune the YOLOv9 model on a custom dataset for personal protective equipment detection. We will be using the personal protective equipment dataset available on RoboFlow. We will download the personal protective equipment dataset from RoboFlow into this Google Colab Notebook, and then we will fine-tune the YOLOv9 model on this personal protective equipment dataset. As now you can see the demo of our output videos which we have got after doing personal protective equipment detection on these videos. We will also see how we can do personal protective equipment detection on images and on videos. I have already prepared a complete notebook for this tutorial, and we will be using YOLOv9 extended model in this tutorial. So let's get started. So now here you can see the complete notebook over here. So I have written all the code and I did all the required explanation as well. And this will provide you a step-by-step guide how you can fine-tune the YOLOv9 model on any custom dataset. But in this tutorial, we will be fine-tuning the YOLOv9 model on personal protective equipment dataset, which is available on RoboFlow. You can gather data from any other resources as well, but I will be using the personal protective equipment dataset, which is available on RoboFlow, and I will show you the dataset as well. So the dataset consists of 7 different classes. As we go ahead, we will discuss that as well. So let's get started with it. So before you run the script, please make sure that you have selected a runtime as T4 GPU. Google Colab offers free GPU, and we can use this as well. So here you can see we have the YOLOv9 GitHub repo, and over here the first step you need to clone this GitHub repo. So you can just copy the link from here, okay, and you can simply add this link over here. After adding this link, we will clone this GitHub repo or in this Google Colab notebook over here. So now you can see here, if I just refresh this, so now you can see the this complete GitHub repo which we have cloned, and we have all the required files over here as well. So now I will just set this YOLOv9 folder as my current directory. So to set any folder as your current directory, you will write cd, and now if I just run this cell, this YOLOv9 folder is being set as my current directory. So if you want to do object detection of images or video, or if you want to fine-tune the YOLOv9 model on any custom dataset, we need to first install all the required packages. So over here, if you just open the requirements.txt file, you will find all the packages that are required to train detection or run the validation script. So you can install these packages one by one, or if you just write pip install -r requirements.txt, it will install all the packages that are mentioned in this requirements.txt file. So now I will just run this, and it will install all the packages that are mentioned in the requirements.txt file. So this will take 2 seconds before all the packages get installed. So it takes around 1 to 2 minutes for all these packages to get installed, and it also depends on the speed of your internet as well. So now you can see over here, I think few more packages are left, and they will take few more seconds to go. Okay, so you can see this is in progress currently. So let's wait for a few seconds for it to get complete. Okay, so like you can see that these are the size of different packages. So after we install all the required packages, then I will download the model weights from the YOLOv9 GitHub repo into this Google Colab notebook. So if you just show you the YOLOv9 GitHub repo over here, okay. So if you just go to releases from here you will find the YOLOv9 model. So YOLOv9 comes with 4 different models: YOLOv9 small, YOLOv9 medium, YOLOv9 compact, and YOLOv9 extended. But currently the weights of YOLOv9 compact and extended are currently available. So if you want to download this model to your Google Colab notebook, you can simply copy link address from here. And if you just see over here, we only have available a YOLOv9 model weights for compact and extended model. The other model weights are not available. So I will just add this link over here, which I have copied, and Before we go ahead with this, we will set this YOLOv9 folder as our current directory. We have all those already set this, but we will save this directory name into a variable which is home. Okay, so now inside this we will create, so using mkdir, we will create a new directory by the name weights inside this YOLOv9. So inside this YOLOv9 folder, we will create another directory by the name weights. Inside this weights folder or directory, we will save our YOLOv9 compact and extended model weights. We will not be using the compact model weight. We will only fine tune the YOLOv9 extended model. So now if I just run this cell, so over here you will see we have created a directory by the name weights, currently it's empty. So now we will download the YOLOv9 compact and YOLOv9 extended model weights into this directory. If I just run this cell now over here, so now if you can see over here, I have downloaded the YOLOv9 compact and extended model weights you can find over here. So you can simply see what different folders you have or what different files you have inside this weights folder. So we have YOLOv9C, which is a YOLOv9 compact model, and YOLOv9 extended model. I already told you YOLOv9 comes with 4 different models: YOLOv9 small, YOLOv9 medium, YOLOv9 compact, and extended. But currently the weights for YOLOv9 compact and extended model are available, so we are just using that. So now I will download a dataset from RoboFlow into the Google Colab Notebook. As I already told you that we will be fine-tuning the YOLOv9 model on personal protective equipment dataset. So if I just open this, let me just open a dataset over here and show you how our dataset looks like. Here, the dataset is available on RoboFlow, and you can see that I have written this own dataset. And the dataset consists of 2,311 training images. 652 images are for the validation and 327 images are for the test set. So we are taking 70% of our data for the training purpose, 20% of the data for the validation purpose, and 10% of the data for the testing purpose. And here, a dataset consists of 7 different classes, which include dust mask, gloves, protective boots, protective helmet, eye wear, safety vest, and shield. So these are the 7 different classes which we have in our data set. And over here, if I just open this data set, you can see over here, these are the protective boots, this is the safety vest, these are the safety vest, this is the protective helmet. Okay, so, and if I just see the health check over here, so in the health check, we can find that if our data is completely balanced or not. So we can see that out of 7, 4 classes are balanced while 3 classes are not balanced. So you can see over here. So this is how our data set looks like. Okay. So now you can see no augmentations were applied in our data set because we usually apply augmentation at that time when we don't have enough images in our training data. So to increase the size of our training data, we usually apply augmentation. But in this case, we already have 2,311 images in our training data. So we don't need to apply augmentation. So now I will just download this data set. So you can simply create an account on RoboFlow. So if you just try it over here, I already have an account on RoboFlow. So you can simply sign in with Google, or if you have already have an account, or you can enter the credentials. So now you can see I've just logged in. It's very simple to create account on RoboFlow. You can simply create. And if you want to download this dataset, you can simply select the format. I will select YOLOv9 format and click on show download code. And if you are using Jupyter Notebook or Google Colab Notebook, then you will simply copy this code from here. But if you are using Visual Studio or PyCharm IDE, then you will just copy this code and paste in the terminal. It will download a dataset from RoboFlow into your IDE. So I will simply copy this code from here and I will just add this code over here. And so now it will download a dataset from RoboFlow into this Google Colab Notebook. So this might take few more seconds before we are able to download the dataset. Okay. So now you can see that warning, the following packages were previously imported in the runtime. You must restart a runtime in order to use newly installed versions. So I will just wait for a dataset to download complete, then I will just restart. Okay. So now you can see the tick mark over here. It means the dataset is downloaded. So I will just restart the session so that package installation can be completely done. So now if I just restart a session, then I just need to select this YOLOv9 folder as my current directory again. Okay. So now you can see over here. So now we need to train our custom model. So if I just open the YOLOv9 GitHub repo over here, so you will find all the steps for the training are written over here. So if you just see over here, so now you can see that if you want to train, okay. So if you want to train YOLOv9 models, you will run the train-mule.py script. And if you want to train a GLAN model, you can run the train.py script. But here I'm going to train the YOLOv9 extended model. So I will just run the Python train-mule.py script. So you can simply copy this line of code from here, and you can just add this line of code over here. And over here, I made few changes. I've just made the batch size at 8, and I'm just trained using GPU. So I've set the device 0. The image size is being set to 640, which is by default. And you know that in the start, I've downloaded the weights from the GitHub repo into this Google Colab Notebook. So over here in the weights folder, you will find the weights over here. So I've written YOLOv9 e.pt. So YOLOv9 extended model weights, and I've just my fine-tuned model weights will be saved in the folder YOLOv9 fine-tuning. So by this name, a folder will be created inside this YOLOv9 directory, and inside this, our fine-tuned model weights will be saved as well. So, and plus I'm fine-tuning the YOLOv9 model for 30 epochs. You can fine-tune the model for 80 or 100 epochs, which is well suited. But in this tutorial, I'm just fine-tuning the YOLOv9 model for 30 epochs, and it gives me good results as well. Plus here, I will just in the data path, I will just pass the name of data.yml file. So if you just see this is the dataset which I have downloaded, and here we have the data.yml file. So you can see that we have 7 different classes in our dataset. Which include dust mask, eye wear, glove, protective boots, protective helmet, safety vest, and shield. And here you can see that training dataset path, validation dataset images path, and test images path. You can see over here. So you just need to add this data.yml file path over here, which I have already added. And plus, you just, as we have restart the session, so you just need to run this cell again over here so that we can set this as our. Just need to run this cell once again. Okay, that's fine. And if you just run this cell, now this will restart the training over here. It will start the training over here. So it will train or fine-tune the YOLOv9 model on personal protective equipment dataset for 30 epochs, which you have mentioned over here. I have already done the training, or I have already fine-tuned the YOLOv9 extended model for 30 epochs on personal protective equipment dataset, which I have shown you. So now you can see over here, and let me just go down. So the training takes a lot of time. So I'm not going to train again. Like previously, it has taken for 30 epochs, it has taken 2.621 hours. Like it has taken around 160 minutes to fine-tune the YOLOv9 model on personal protective equipment dataset for 30 epochs. And in the end, we got the best model weights and the last model weights on the last epoch. And the best model weights represents the epoch on which the model gives the best mean average precision scores. And the last .pt basically are the model weights on the last epoch, which is the 30th epoch. Okay. And from here, you can see, if you just see mean average precision, like you can see here, class-wise, the mean average precision with IIU 0.5, and the mean average precision when IIU varies from 0.5 to 0.95. So now you can see over here, we have the mean average precision for the dust mask, eye wear, glove, protective boots, protective helmet, safety vest, and shield class. So from here, you can see that the mean average scores are very good. Like we have for all the 2 classes, we have mean average precision score above 90% for IIU 0.5, and for only one for for only two classes, we have mean average precision with IOUs 0.4 scores below 90%. One is 0.845 for IBR, and for the shield class, we have the mean average precision score with IOU 0.5 as 0.761 or 76.1%, while the mean average precision score when IOU varies from 0.5 to 0.95 are pretty good as well, which you can see over the values over here. So the results are very promising for now. Okay, so I have already fine-tuned the, okay, just let me just save these changes. So as I already told you, I've already fine-tuned the YOLOv9 model for the personal predictive data set. So after fine-tuning this, I have saved the best model weights into my drive. So I will directly download the best model weight from drive into this Google Colab Notebook. And then we will do inference on images and on videos on these best model weights. So here we have the results, which you usually get after training. So now you can see the mean average precision score is continuously increasing and it goes up till above 90%. While you can see that mean average precision score when IU varies from 0.5 to 0.95 is also increasing and goes up to 65% as well, while the loss is continuously decreasing. So this is very good. Okay, so here we have the confusion matrix. So the confusion matrix basically tells us how our model handles different classes. So over here, like you can see, this is the confusion matrix chart. And here you can see we have all our 7 different classes: dust mask, IVR, glove, protective boots, protective helmet, safety vest, shield, and background when the thing is detected. And we have all these class names mentioned over here as well. So if we just see from the dust mask, so 94% of the times when there is a dust mask or when the person is wearing the dust mask, 94% of the times our model correctly detected that the person is wearing the dust mask. So 0.94 means 94% of the times when the person is wearing a dust mask, our fine-tuned YOLOv9 model correctly detects that the person is wearing a dust mask. While 6% of the times when the person is wearing a dust mask, our model is unable to detect anything. So here you can see 0.06. So 6% of the times when the person is wearing a dust mask, our model is unable to detect anything. So next is IVR. So 86% of the times when the person is wearing the IVRs, our model correctly detects that the person is wearing the IVRs. While 1% of the time when the person is wearing dust mask, our model incorrectly, 1% of the time when the person is wearing IVR, our model incorrectly classified it as dust mask. So 86% of the times when the person is wearing IVR, our model correctly detects that the person is wearing IVR, while 1% of the times when the person is wearing IVR, our model incorrectly detects it as dust mask. While 42% of times when the person is wearing IVR, our model is unable to detect anything. Okay, and again, like you can see over here, shield for the shield case, 76% of the times when the person is wearing shield, our model correctly detects that the person is wearing a shield. While 4% of the times when the person is wearing a shield, our model incorrectly detect it as protective helmet. So 4% of the times when the person is wearing a shield, our model incorrectly detects it as protective helmet. While 20% of the time when the person is wearing a shield, our model does not detect anything. Okay, so this is how confusion matrix. So these are the model predictions for the validation batch. We have not used these images for our training, so it's always better to take a look and see how our model performs. So from here, you can see we have IVR, shield, protective helmet, and so on, so forth. So the results from here are very promising. So now we will do model. So now we will just evaluate our model on the validation set images and see how our model performs. So now we are just evaluating our model on the validation data set images. And over here, you can see that the results are quite promising. And you can see over here, we have got very good mean average precision score with IU 0.5 and very good mean average precision score when IU varies from 0.5 to 0.95. So now we will be doing inference on images and videos over here. So you can download these two videos. I've already placed those videos into my drive. So I will directly download those videos from drive into this Google Colab Notebook. So I'm downloading these two videos. So now, first of all, if you just see over here, so now you do inference with YOLOv9 model. So you will just Python detect dash YOL.py. And if you want to do inference with Glen model, you will run the detect.py script. So as I want to do inference with YOLOv9 model on image, so I will just run detect dash YOL.py. And if I want to do inference on videos, I will run the same script. And here I've just passed the source image, and I've just passed the best model weights, which I have downloaded from Drive. And I've selected a device as GPUs, DRAM increment GPU. And if you just write, you want to use CPU, you can simply write CPU over here. Okay, so now our output image is saved in this folder. So if you just see over here, runs, detect, and in this folder, we have the output image. So I've already added this path over here. So let me just display this output image over here. Okay. So I think there is an error. So I think I've just, if I just copy this from here and see where I have placed my image library. Where, okay, I think I've just give me a minute. Let me see where we have, or we can just initialize this library again. Okay, so here you can see we have the library. So this image library helps us to display an image into our Google Colab Notebook. So now it will display the output image over here. So let's mark this cell again. So now you can see we have tested on this random image, and we are able to detect a protective helmet and the safety vest that this person is wearing. So now we will just do the inference on the videos, two videos which we have downloaded. So now you can see the inference has started. So let's see how it goes. So we are using the best model weights. So our complete video is being divided into 310 frames, and we will be doing detections on each of the frame one by one. Like you can see over here, we are able to detect the protective helmet, safety vest, protective boots, and so on. And the results look quite good, like 6 protective boots, 3 protective helmets, 6 safety vests, 5 safety vests the person are wearing. So okay, so now you can see over here, and let's display the output video into this Google Colab Notebook over here as well. So this might take few more seconds before we have the results. So let's wait and see how does it goes over here. So after this, we will be doing detections on this PP part 2 videos, as we have downloaded 2 videos. So now we are doing inference on this video. After this, we will perform inference on this second video as well. Okay. So this might take few more seconds before it gets completed. So here is our output video. So let me download this video first, and let's see how does it goes. So over here, if I just open this video now, and let me just navigate my screen towards the output video. So over here, you can see that we are able to detect a safety vest, protective helmets, protective boots. So now you can see the results look very promising from here. Okay. And if I just go again over here, okay. And now we will, okay. Just give me a second. Now we will do inference on the second video using the fine-tune YOLOv9 model on personal protective, which we have fine-tuned on the personal protective equipment dataset. So now we are doing inference on the second video over here. So this might take few more seconds before it gets. So the complete video is being divided into 267 frames. Okay, over here, and like you can see over here, we are doing detection on each of the frame one by one. So it's quite good and it's going quite good. So it will be finished soon. So now you can see the processing is done. So let me display this output video over here. Okay. So this might take few seconds before we have the output video over here. So here is our output video. And let me just download this first. And let me just open it. So let me first navigate my screen towards it. So over here, you can see that we are already able to detect a safety vest, protective boots, helmet as well. And the results look very promising as well. So in this tutorial, we have learned that how we can do personal protective equipment detection on images and videos. And we have also learned that how we can fine tune the YOLOv9 model on any custom data set. Like you can also fine tune the YOLOv9 model on helmets data set or on any cars data set, or you can also do on any other data set. You can also fine tune the YOLOv9 model on license plate data set, pens and books data set, potholes data set, and so on. There are so many applications, like you can fine tune the YOLOv9 model on grocery data sets as well. So there are so many applications that exist. You just need to explore that as well. So that's all from this tutorial. Thank you for watching.